Picture this: a world where the ground beneath your feet is alive, shifting and colliding in slow motion over millions of years. Now, look up, and there they are, the Himalayas, the tallest mountains on Earth, their snow-capped peaks piercing the sky like ancient sentinels. These giants didn't just appear overnight. They're the result of one of the most dramatic geological showdowns in our planet's history, a clash so monumental it reshaped continents and rewrote the very rules of our world. But how did these colossal peaks come to be? The story is equal parts science and legend, a tale of titanic forces and timeless myths that still leave experts in awe today. For centuries, the Himalayas have been shrouded in mystery. To some, they're the abode of gods, a sacred realm where heaven and earth meet. To others, they're a puzzle written in rock, a riddle waiting to be solved by the sharpest minds in geology. We know the basics: the Indian tectonic plate smashing into Eurasia, pushing the land upward in a slow-motion collision that's still happening today. But that's just the beginning. Why here? Why so extreme? And what secrets lie buried beneath those towering summits? The answers are stranger and more fascinating than you might imagine, weaving together ancient folklore, cutting-edge science, and discoveries that challenge everything we thought we knew. This isn't just a story about rocks and pressure. It's a saga of our planet's restless energy, of continents that move like drifting giants, and of mountains that grow taller even as we speak. Over the next few minutes, we'll travel back in time to unravel the Himalayas' origins, from the wild myths whispered by ancient cultures to the groundbreaking theories that revolutionized geology. We'll meet the scientists who have risked everything to decode these peaks, and we'll uncover the lingering mysteries that still keep them up at night. So buckle up, you're about to witness Earth's greatest creation story, a drama written in stone and still unfolding before our eyes. The journey begins now. Long before geologists pieced together the puzzle of tectonic plates, cultures across the Himalayas wove their own explanations for these towering peaks, stories where gods shaped the land with divine hands. In Hindu tradition, Mount Kailash isn't just a mountain. It's the throne of Lord Shiva, the destroyer and transformer, who sits in eternal meditation, his presence infusing the rocks with sacred energy. Pilgrims still circle its base today, believing a single glance at its slopes can erase lifetimes of sin. Meanwhile, Tibetan lore speaks of hidden valleys within the Himalayas, realms where enlightened beings dwell in secret, waiting to guide humanity. These aren't just tales, they're maps of the soul, turning jagged cliffs into symbols of transcendence. Venture into Nepal, and the mountains breathe with life. The Sherpa people revere Everest as Chomolungma, the mother goddess of the world, a protector whose glaciers give water to millions downstream. In Bhutan, peaks like Jomolhari are said to be home to wrathful deities, their storms a reminder of nature's untamable power. What's striking isn't just the diversity of these myths, it's their shared awe. Whether as divine thrones or living spirits, the Himalayas have always been more than rock and ice. They're a mirror reflecting humanity's deepest questions. How did such giants come to be, and what forces, earthly or otherwise, could birth them? Science, of course, offers its own epic, one of colliding continents and grinding rock. But here's the fascinating twist: the myths weren't entirely wrong. When ancient cultures described the mountains as alive or divinely shaped, they sensed a truth geology would later confirm. The Himalayas are restless, rising higher each year as India pushes relentlessly northward. The difference, where myth saw gods, science sees gravity and friction, the slow dance of a planet rearranging itself. Yet both agree on one thing: these mountains are anything but ordinary. They defy scale, defy time, and in their shadows, the line between legend and reality blurs. So the next time you see a Himalayan peak, ask yourself, is it just a mountain or a story still being written? By the 19th century, as explorers scaled the Himalayas' lower slopes, scientists back in Europe were wrestling with a mystery just as daunting: how did these impossible mountains form? Their best theories, crafted with little more than hammers and notebooks, reveal just how far geology has come. One popular idea, called the contraction theory, painted an almost poetic picture. As Earth cooled from its fiery birth, they argued, its crust shriveled like the skin of an apple left in the sun. The Himalayas, in this view, were simply wrinkles in a planet slowly drying out. It was elegant, intuitive, and completely wrong. Enter Eduard Suess, an Austrian geologist whose name still echoes in textbooks today. Staring at fossil records and rock layers, he noticed something peculiar: identical marine creatures buried in the mountains of Europe and India, despite being separated by thousands of miles. His explanation: a vast, ancient sea he named the Tethys Ocean once bridged these lands, its sediments crushed and lifted as continents collided. It was a stroke of genius, though Suess couldn't yet grasp the full picture. Without satellites or seismographs, he and his peers were like detectives trying to solve a crime scene with only a handful of clues. They mapped faults by foot, estimated ages by rock types, and debated fiercely over sketches of landscapes they'd never seen firsthand. What's remarkable isn't just how much they got wrong, it's how much they got right with so little. When Suess imagined the Tethys, he was describing the ghost of an ocean we now know existed, one swallowed by the slow dance of tectonic plates. Modern tools would later reveal the truth. India wasn't just nudging Eurasia, it was plowing into it at the speed fingernails grow, dragging the seafloor upward into jagged peaks. But those early geologists, armed with little more than curiosity, laid the groundwork for every discovery that followed. Their theories, though flawed, were the first cracks in a mystery that would take a century to solve, proof that even the grandest truths begin as humble guesses. Alfred Wegener wasn't your typical scientist. He was a meteorologist, an adventurer, and a man with a theory so radical it would take 50 years for the world to catch up. Picture him in 1912, standing before a room of skeptical geologists, holding a map that would change everything. He'd cut out the continents like pieces of a jigsaw puzzle and noticed something astonishing. South America's eastern bulge fit snugly into Africa's western curve. Brazil's coastline nestled against Nigeria like long-lost siblings. But Wegener didn't stop there. Fossils of identical tropical plants were found in icy Antarctica, while matching reptile skeletons turned up in India and Africa, lands now separated by vast oceans. His conclusion: the continents weren't fixed. They were drifting slowly but relentlessly across Earth's surface. To Wegener, the Himalayas weren't just mountains, they were crash zones, the crumpled front end of India's northward charge into Asia. He imagined continents plowing through ocean crust like icebreakers cutting through frozen seas, their collisions wrinkling the land into towering peaks. It was a breathtaking vision, one that turned Earth into a dynamic, ever-shifting puzzle. But the scientific establishment wasn't ready. Critics mocked his lack of geological training, dismissing continental drift as fantasy. What force could possibly move something as massive as a continent? They demanded. Wegener's answer: tidal forces from the Moon and Earth's rotation, wasn't strong enough, and without a clear mechanism, his theory languished in obscurity. Yet Wegener's genius lay in seeing connections others missed. He noticed that coal deposits formed in ancient swamps appeared in frigid Arctic regions, while glacial scars from long-ago ice sheets lined up across now distant continents. His maps showed mountain ranges that abruptly ended at one coastline only to resume across an ocean, as if torn apart by invisible hands. The evidence was there, scattered like breadcrumbs across the planet. But without the tools to measure continental movement, his ideas remained a footnote in geology textbooks until the mid-20th century, when wartime technology finally unveiled Earth's hidden machinery. The vindication came from an unexpected place, the ocean floor. Researchers mapping the Atlantic with sonar discovered a sprawling underwater mountain range, its valleys oozing molten rock that pushed older crust aside like a conveyor belt. Here, at last, was Wegener's missing mechanism, not continents plowing through oceans, but entire plates of Earth's crust floating atop a churning mantle, carrying land masses with them. The Himalayas, it turned out, weren't just a collision. They were an ongoing traffic jam between two titanic plates, with India still shoving its way north at 2 inches per year. Wegener hadn't been wrong, he'd just been ahead of his time. His rafts were real, and his drifting continents were the key to unlocking Earth's greatest geological mysteries. The irony, by the time proof arrived, Wegener had long since vanished into Greenland's ice, his body lost to the very forces he'd spent his life trying to understand. The 1960s brought a revolution in geology, one that finally unlocked the mystery Wegener couldn't solve. It began with an accidental discovery during World War II, when naval ships scanning the ocean floor with sonar stumbled upon something extraordinary, a colossal underwater mountain range snaking through the Atlantic like the stitches of a planetary seam. This was the Mid-Atlantic Ridge, a place where molten rock bubbled up from Earth's depths, creating new crust that pushed older sections aside. But the real revelation came when scientists noticed something even stranger. The ocean floor wasn't just spreading, it was vanishing in places, swallowed back into the planet along deep trenches near continents. Suddenly, the pieces clicked into place. Enter Harry Hess, a geologist and Navy submarine commander who'd seen these ridges firsthand during wartime missions. He proposed a radical idea: Earth's crust wasn't static, but broken into giant, shifting plates floating atop a churning layer of semi-molten rock called the mantle. Where plates pulled apart, magma rose to form new crust. Where they collided, one plate dove beneath another in a process called subduction, melting back into the planet's furnace. It was the missing mechanism Wegener had dreamed of, a conveyor belt of rock that could move continents without breaking them. Then came J. Tuzo Wilson, a Canadian scientist who took Hess's theory even further. He realized that the Himalayas weren't just a random collision, they were part of a global pattern. India, once attached to Antarctica, had broken free and raced northward, riding a plate that eventually slammed into Eurasia. The force was so immense that instead of subducting, the two continents crumpled upward, stacking rock upon rock like a slow-motion car crash. Wilson's genius was seeing the bigger picture. Earth's surface was a mosaic of interlocking plates, each with its own story of movement and collision. This wasn't just a theory, it was a paradigm shift. Plate tectonics became the backbone of modern geology, explaining everything from earthquakes to volcanoes to the very shape of our continents. And for the Himalayas, it meant something profound. These mountains weren't relics of the past. They were alive, still rising as India continues its relentless push, adding tiny increments of height each year. The ground beneath Everest, it turns out, is still climbing, a reminder that Earth's greatest stories are still being written. Before the Himalayas scraped the sky, there was an ocean, an azure world so vast it could swallow continents. This was the Tethys, a tropical paradise stretching between India and Eurasia over 140 million years ago. Its warm waters teemed with life, spiral-shelled ammonites drifting like underwater balloons, schools of prehistoric fish darting through coral reefs, and giant marine reptiles gliding past submerged volcanoes. Today, you can still find traces of this lost world not underwater, but at the top of Everest. Fossilized seashells embedded in the summit's limestone are silent witnesses to a time when the planet's highest point lay beneath the waves. India's journey northward began as the Tethys' seafloor acted like a slow-motion treadmill. Picture this: as magma bubbled up along mid-ocean ridges, it pushed the ocean crust outward, carrying India away from Africa and toward Eurasia. Over millions of years, the Tethys narrowed, its seafloor diving beneath Asia's edge in a process called subduction, like a conveyor belt vanishing into Earth's depths. But here's where things got dramatic. Unlike typical oceanic crust, which sinks easily, India was riding a slab of continental rock, thick and buoyant. When it reached the subduction zone, it didn't dive. It plowed forward, squeezing the Tethys' remains like toothpaste from a tube. The collision was inevitable. As India rammed into Eurasia, the ocean floor between them had nowhere to go but up. Sediments that once lined the Tethys' coral reefs, volcanic ash, the skeletons of countless sea creatures, were scraped off the descending plate and stacked into towering piles. Layer upon layer crumpled, folded, and fractured, transforming what was once a seabed into the foundation of the world's highest peaks. Today, geologists find marine fossils not just near Everest, but across the entire Himalayan range, a ghostly reminder that these mountains were born from the bones of an ancient sea. But the most astonishing part: this process isn't over. India continues its northward march, still pushing against Asia at nearly 2 inches per year. The Himalayas grow taller by a fraction of an inch annually, their rocks still folding under immense pressure. The Tethys may be gone, but its legacy lives on not just in fossils, but in the very forces that keep these mountains alive, rising ever higher into the sky. Imagine a continent on the run, a landmass so determined to change the world it crossed an entire ocean in a 50-million-year sprint. That's India's story, a geological road trip unlike any other. Breaking free from Antarctica around 140 million years ago, this rebellious landmass took off northward at a blistering 15 centimeters per year, racing across the Tethys Ocean like a skater gliding over ice. To put that in perspective, that's about the speed your fingernails grow, except India wasn't a tiny sliver of keratin. It was a colossal slab of rock, dragging entire ecosystems with it, reshaping ocean currents and climate patterns as it plowed forward. Then, around 50 million years ago, something strange happened. Just as India was about to smash into Asia, it slammed on the brakes. Its speed dropped by half, as if hitting an invisible wall. Geologists call this the hard brake mystery, and the clues lie in the rocks themselves. Deep beneath the Indian Ocean, scientists have found magnetic fingerprints frozen in ancient lava minerals that aligned with Earth's magnetic field as they cooled, locking in a record of India's frantic journey. These paleomagnetic snapshots reveal not just where India was, but how its trajectory suddenly changed. Some theories suggest the continent met resistance from thickened ocean crust or a hidden mantle plume, like a runner tripping over an unseen hurdle. Others propose the sheer weight of the Tethys seafloor piling up ahead of India acted like a natural speed bump. But slow or not, India wasn't stopping. When it finally collided with Eurasia, the impact was anything but gentle. Picture 2 continents playing geological chicken, neither willing to yield. Unlike oceanic crust, which can dive neatly beneath another plate, India's thick continental rock refused to subduct. Instead, it bulldozed into Asia, crumpling the land ahead of it like a rug shoved against a wall. The Tethys Ocean's sediments, once a tranquil seabed, were scooped up and stacked vertically, layer upon layer, in a chaotic riot of rock. This was no tidy collision. It was a continental train wreck in slow motion, with the Himalayas emerging from the wreckage. What's wild is that this crash is still happening. India hasn't stopped pushing, it's just grinding forward at a slower, more stubborn pace, like a determined neighbor rearranging the fence line inch by inch. The Himalayas continue to rise, their rocks folding and fracturing under the strain. Earthquakes ripple through the region as the plates stick, slip, and readjust, reminders that this geological drama is far from over. So the next time you see Everest's snowy peak, remember, it's not just a mountain. It's the skid mark of a continent that refused to stay put, a monument to Earth's restless, relentless creativity. Think of the most violent car crash imaginable. Now multiply that force by trillions and stretch it over 50 million years. That's what happened when India finally collided with Eurasia. An impact so colossal it released energy equivalent to detonating every atomic bomb ever built, thousands of times over. But this wasn't a quick, explosive smash. It was more like two continents playing a brutal, slow-motion game of bumper cars with neither willing to back down. The result, a geological traffic jam of unimaginable scale, where rock layers didn't just pile up, they twisted, folded, and snapped under pressures that would turn steel into putty. Picture pushing a rug against a wall. At first, it bunches up in smooth waves, but keep pushing, and the fabric starts to buckle unpredictably, forming jagged peaks and deep creases. That's exactly how the Himalayas formed, except instead of fabric, it was solid rock behaving like taffy. The Indian plate didn't just nudge Eurasia, it plowed into it with enough force to crumple the entire region. Ancient seabeds were hoisted vertically, turning what was once horizontal layers of sediment into near vertical cliffs. Fault lines zigzagged through the crust like shattered glass, with some rock layers sliding over others for miles. This wasn't a neat stack of pancakes, it was a geological origami project gone wild, with folds so tight they could bury mountains within mountains. Here's where things get even stranger. The Himalayas didn't rise evenly like a loaf of bread in the oven. Some sections shot upward faster than others, creating a patchwork of peaks and valleys. The force was so intense that deep underground, rocks actually began melting, not from heat but from sheer pressure, a process called crustal thickening. Imagine squeezing a chocolate bar until it oozes between your fingers, except instead of chocolate, it's granite and gneiss flowing like syrup over geological time. This explains why the Himalayas aren't just tall, they're deep, with roots extending over 100 miles into the earth, far thicker than average continental crust. And here's the kicker, the crash isn't over. India is still inching northward today, bulldozing into Asia at roughly the speed your hair grows. Everest gains about a quarter inch of height each year, while the entire Himalayan range acts like a giant spring, storing tectonic stress until snap, an earthquake releases it in seconds. That's why this region shakes so violently. It's the sound of continents still arguing over who gets the right of way. So next time you see a photo of those towering peaks, remember, you're not looking at a static monument. You're witnessing a live construction site where Earth's crust is still under the hammer, reshaping itself 1 millimeter at a time. Everest isn't just sitting there, frozen in time, it's alive, breathing, and growing at a pace you could measure with a ruler if you had enough patience. Every year, the world's tallest peak stretches a little higher, gaining about 4 millimeters in height. That might not sound like much, but over a decade, it adds up to nearly 1.5 inches. And here's the wild part. We know this thanks to GPS receivers bolted into the mountain's bedrock, sending real-time data as India's relentless push flexes the crust like a slow-motion trampoline. These sensors don't just track elevation, they capture the Himalayas' pulse, revealing how the entire region is stretching, compressing, and writhing under tectonic stress. But growth isn't Everest's only story. Gravity is constantly working to pull it back down, while wind, ice, and rain wage a never-ending war of erosion. Think of it as a cosmic balancing act, one force pushing up, the other scraping away. Some studies suggest erosion shaves off roughly 0.5 millimeter annually, meaning Everest's net growth is more like 3.5 millimeters per year. That's the delicate dance that keeps these peaks from skyrocketing into the stratosphere. Yet every now and then, nature throws a curveball. Take the massive Nepal earthquake in 2015, which clocked in at 7.8 magnitude. In just 30 seconds, the ground lurched, and satellite data showed entire sections of the Himalayas lurching upward by several feet. Everest itself may have lost a sliver of height in that event, but nearby peaks like Langtang grew almost instantly, proof that mountains don't always rise gracefully. So will Everest someday pierce the 9-kilometer mark? The math says it's possible in about 100,000 years at current rates. But here's the catch: the higher it climbs, the harder gravity fights back. Rock avalanches become more frequent, glaciers carve deeper valleys, and the very weight of the mountain begins to crush its own base. Some geologists argue there's a natural ceiling, a point where uplift and erosion reach equilibrium. Others point to ancient mega-mountains that may have once dwarfed Everest, only to be ground down by time. The truth is, Everest's fate isn't written in stone. It's written in the push and pull of forces far beyond our control, a reminder that even the mightiest peaks are just temporary players in Earth's ever-changing drama. The Himalayas hold secrets that sound like something out of science fiction, like the fact that climbers on Everest's summit are literally standing on the bottom of an ancient ocean. Embedded in that frostbitten rock are fossils of tiny sea creatures called crinoids, their delicate stems preserved in limestone that once formed the floor of the Tethys Ocean. It's as if Earth flipped the script, hoisting a seabed 8,000 meters into the sky. But that's just the start. Deep in the Himalayas' heart, geologists have found minerals like coesite and stishovite crystals that only form under pressures so extreme they're usually reserved for meteor impacts or the mantle's crushing depths. These aren't just rocks, they're time capsules, proof that Himalayan peaks were once buried dozens of kilometers underground before being spit back to the surface like geological jack-in-the-boxes. Then there's the mystery of the Sikkim-Klippen, a German term meaning cliffs that barely scratches the surface of how bizarre these formations are. Picture a layer of ancient 2-billion-year-old rocks perched precariously atop much younger strata, like a pancake balanced on a tower of Jenga blocks. These klippen are the remnants of a colossal thrust sheet, a slab of crust that got shoved horizontally for miles during India's collision, then eroded until only these isolated fragments remained. It's as if someone took a geological bulldozer, scraped up a section of Earth's crust, and slid it across the landscape like a tablecloth over a bumpy table. For scientists, these oddities are more than curiosities, they're clues to reconstructing a collision that defies imagination. But perhaps the most unsettling revelation is what these features say about the Himalayas' future. Those ultra-high-pressure minerals, they're evidence of rocks being dragged so deep they should have melted, yet somehow they survived intact. That means the forces at work here are even more violent than we thought, with chunks of crust being recycled like ingredients in a planetary blender. And the klippen, they're proof that these mountains aren't just rising, they're spreading, with layers peeling apart like an onion under tectonic stress. Every bizarre feature whispers the same warning. This collision isn't done reshaping the land, which brings us to the Himalayas' most unpredictable actors, earthquakes. The ground-shaking reminders that this geological drama is still being written, one violent tremor at a time. The Himalayas don't just rise, they groan. Every creak and shudder echoes the immense tectonic forces still reshaping this landscape. And nowhere is that more terrifyingly clear than in the earthquakes that ripple through the region. Take the 2015 Nepal quake. In less than a minute, the ground convulsed with the energy of 23 nuclear bombs, flattening villages and shifting Mount Everest by nearly an inch. But what made this disaster so destructive wasn't just raw power. It was decades of pent-up strain finally snapping. The quake's epicenter lay in a locked zone, a section of the Indian plate jammed beneath Eurasia like a stuck drawer, silently accumulating stress until the rocks could no longer hold. These locked zones are the Himalayas' hidden time bombs. Imagine bending a wooden ruler until it splinters. That's essentially what happens when tectonic strain overcomes friction, except the ruler is a 100-mile thick slab of crust. Survivors of the Nepal quake describe the moment in haunting detail. The sound of buildings collapsing like card towers, the dust-choked air, the eerie silence that followed. One Sherpa guide interviewed near Everest Base Camp recalled watching the Khumbu icefall, a treacherous glacier already infamous among climbers, crack apart as if the mountain itself were exhaling. These aren't just statistics, they're visceral reminders that plate tectonics isn't abstract science. It's a force that rewrites lives in seconds. Now, scientists are racing to map the next potential rupture. Using GPS stations and satellite radar, they've identified a massive locked zone beneath western Nepal, where the Indian plate hasn't slipped significantly in over 500 years. The math is sobering. If it releases all its stored energy at once, the resulting quake could top magnitude 8.5, the big one seismologists dread. But predicting when is fiendishly hard. Earthquakes don't run on schedules, and the Himalayas' labyrinth of faults makes the region a geological minefield. Some researchers track subtle ground tilts or spikes in radon gas, while others study historical records of past quakes, looking for patterns in the chaos. Yet these tremors also offer clues to the mountain's hidden anatomy. Each quake acts like an X-ray, sending seismic waves that reveal buried faults and rock densities. After the 2015 disaster, scientists discovered previously unknown fractures snaking beneath Kathmandu, explaining why the city's valley shook like a bowl of jelly. Others found evidence that the main Himalayan thrust, the mega fault where India grinds under Eurasia, isn't one clean slope but a series of jagged steps, each capable of unleashing its own disaster. It's a grim trade-off. Every quake brings devastation but also data, helping us glimpse the machinery beneath our feet. And in a region where millions live in the shadow of the next big shake, that knowledge isn't just academic, it's a lifeline. Beneath the Himalayas, the real action is hidden from view, a subterranean spectacle where continents don't just collide, they merge in ways that defy logic. Picture the Indian plate as a colossal whale diving beneath Asia, but instead of sleek motion, it's more like peeling an orange in reverse. The crust doesn't slide smoothly. It crumples, fractures, and folds, creating a messy, tangled boundary that seismologists call the main Himalayan thrust. This isn't just a fault line, it's a geological wrestling match, with one continent trying to shove the other into Earth's molten mantle. Seismic waves act like X-rays for the planet, revealing secrets no drill could ever reach. When earthquakes rattle the region, their vibrations travel through the crust, speeding up or slowing down depending on the rock's density. These waves have uncovered something bizarre. The Indian plate isn't just diving, it's doubling down. Beneath Tibet, the crust measures a staggering 60 to 70 kilometers thick, nearly twice the global average. It's as if the collision didn't just stack mountains, it stacked the very foundation of continents, creating a route so deep it rivals the height of Everest above ground. How does crust even get this thick? Think of two cars colliding head-on, their hoods crumpling upward. Now imagine that happening over millions of years, with rocks piling so high they begin to sink under their own weight. Some sections melt, oozing back into the mantle like candle wax, while others stubbornly cling together, forming a dense, tangled knot. But here's the twist, not all of this thickening comes from the Indian plate. Scientists have found chunks of ancient Asian crust mixed into the mess, like two colors of Play-Doh mashed together by a toddler with unlimited time. And then there's the mystery of the dripping lithosphere. Some models suggest that parts of this thickened crust are so heavy, they're breaking off like glacial icebergs, sinking into the mantle in blobs that trigger volcanic eruptions hundreds of miles away. It's a slow-motion demolition job, with Earth recycling its own skin in ways we're only beginning to understand. But the biggest question remains, what's happening at the very bottom? The Indian plate might extend 1,500 kilometers beneath Tibet, far deeper than anyone once thought. Some researchers argue it's flat as a pancake at that depth, sliding horizontally like a stealth submarine. Others believe it's buckling into folds, creating underground mountain ranges we'll never see. One thing's certain, this isn't just geology. It's a planetary-scale experiment, unfolding in real time, with the Himalayas as its most visible and breathtaking side effect. Beneath the Himalayas, hidden from view, lies one of Earth's most enigmatic boundaries, the Mohorovicic Discontinuity, or simply the Moho. This invisible line separates the brittle crust we live on from the seething mantle below, a frontier as mysterious as the ocean's deepest trenches. Imagine slicing into a layered cake, only to find the frosting and sponge twisted into strange, uneven shapes. That's the Moho beneath these mountains. Unlike most places on Earth where this boundary sits roughly parallel to the surface, the Himalayas' Moho is a chaotic mess, warped and contorted by the same forces that built the peaks above. The story of the Moho's discovery reads like a geological detective novel. In 1909, Croatian scientist Andrija Mohorovicic noticed seismic waves from distant earthquakes suddenly speeding up as they passed beneath Europe's Alps. This sudden jump in velocity revealed a hidden interface where dense mantle rock began. But the real drama came decades later, when Soviet scientists launched the most ambitious drilling project in history, the Kola Superdeep borehole. Their goal, to punch through the crust and touch the Moho itself. After 24 years of drilling, they reached 12 kilometers down, barely a third of the way before heat and pressure forced them to abandon the quest. The Earth, it seemed, wasn't ready to give up its secrets. What makes the Himalayas' Moho so bizarre is how deeply it plunges. While most continental crust averages 30 to 50 kilometers thick beneath the Tibetan plateau, the Moho dives to a staggering 80 kilometers, twice the height of Everest inverted. This isn't just a gentle slope, it's a crumpled, folded mess like a rug shoved under a door. The reason? India's continental plate isn't just colliding with Asia, it's delaminating, peeling apart like an onion. The upper crust crumples into mountains while the lower crust peels away, sinking into the mantle in dense, dripping blobs. This warped boundary holds clues to the Himalayas' fate. A shallow Moho would mean the mountains are light and buoyant, destined to rise higher. But this ultra-deep version suggests something darker, a crust so heavy it's already collapsing under its own weight. Some geologists believe this sinking route could eventually drag the entire range down, triggering a slow-motion collapse over millions of years. Others argue the opposite, that as India keeps pushing, this thickened crust will only grow taller, defying gravity's pull. One thing's certain, the Moho isn't just a static line. It's a living, shifting testament to the forces still shaping our planet, a reminder that even the mightiest mountains are just temporary wrinkles in Earth's restless skin. High in the thin air of the Himalayas, where most life struggles to survive, glaciers thrive, silent, slow-moving rivers of ice that hold secrets older than human civilization. These frozen giants aren't just scenic backdrops, they're time capsules layering snow year after year like pages in a history book. Drill into one and you'll find more than ice. You'll uncover ancient air bubbles trapped for millennia, volcanic ash from eruptions that darkened skies centuries ago, even traces of lead from Roman smelters carried by winds across continents. Each layer tells a story, preserving snapshots of Earth's past climate with startling precision. Take the Dasuopu Glacier in Tibet, where scientists extracted ice cores dating back 600 years. Buried in those frozen strata, evidence of monsoon patterns that shaped empires, with thick layers marking wet years that fed harvests, and thin bands revealing droughts that toppled dynasties. But the real shock came when researchers found spikes of toxic metals like cadmium and zinc, pollution from 19th century coal burning in Europe, hitchhiking on atmospheric currents to freeze atop the world. These glaciers remember everything from industrial revolutions to atomic bomb tests, their ice acting as a ledger of human recklessness written in isotopes. Yet these icy archives are vanishing before we can read them all. As temperatures rise, glaciers retreat at alarming speeds, exposing relics long entombed. In 2017, trekkers near the Lhotse Glacier stumbled on something chilling: the wreckage of a World War II-era US military plane, its aluminum fuselage emerging from the ice after 70 years. Nearby, climbers have found artifacts from early 20th century expeditions, even the frozen remains of long-lost mountaineers. These finds are poignant reminders that glaciers don't just preserve climate data. They're frozen graveyards of human ambition, now thawing under a warming sky. The loss goes beyond history. Himalayan glaciers are Asia's water towers, feeding rivers that quench the thirst of nearly 2 billion people. Their meltwater fills the Ganges, the Indus, the Brahmaputra rivers that are lifelines for farming, drinking, and hydropower. But the system is breaking down. Early melt triggers catastrophic floods, like the 2013 Uttarakhand disaster that killed thousands. Later, as glaciers shrink, the opposite threat emerges: drought. Communities that relied on predictable seasonal flows now face erratic supplies, their futures as uncertain as the next monsoon. What else might these glaciers reveal as they retreat? Buried viruses dormant for millennia, lost settlements swallowed by ice ages, or perhaps clues to civilizations we've forgotten. The irony is bitter. The very forces destroying these frozen libraries are the ones we need them to help us understand. As the ice whispers its final secrets, one thing becomes clear: the Himalayas glaciers aren't just melting. A priceless record of our planet's past, and maybe our future, is slipping away with every drop. Rivers don't bow to mountains, they fight back. While the Himalayas clawed skyward, ancient waterways like the Ganges performed a breathtaking act of defiance, carving their paths through the rising rock rather than around it. These are called antecedent rivers, stubborn channels that existed long before the mountains beneath them began to grow. Picture a saw blade slicing upward through a log as someone lifts the timber. That's essentially what the Ganges did, etching its deep gorges faster than tectonic forces could hoist the land. The result, spectacular chasms like the Mahabharat Range, where the river slashes through stone with such force that its cliffs expose layer upon layer of Earth's violent history. Then there's the Brahmaputra, a river with an identity crisis. Today, it makes a hairpin turn so sharp it looks like a cartographer's mistake, pivoting near the India-China border to charge south into Bangladesh. But this wasn't always its route. Millions of years ago, the Brahmaputra likely flowed straight east into what's now Myanmar until tectonic chaos intervened. As the Himalayas rose, they may have literally stolen the river, redirecting its waters through a process called stream capture. Imagine two rivers flowing on either side of a growing ridge. The steeper gradient on one side eventually allows it to erode backward, pirating the other's flow like a highway rerouting traffic. Evidence lies in the Brahmaputra's sediments, grains of mineralogy that match rocks from Tibet, not Bangladesh, suggesting its waters once came from entirely different headwaters. This isn't just geology, it's a heist story written in water and stone. River piracy reshapes landscapes with the subtlety of a thief in the night. In the Siang Valley, tributaries of the Brahmaputra show telltale signs of past captures, sudden bends, abandoned valleys, and gravel deposits that don't match their current path. Even the Ganges isn't innocent. Researchers believe it once stole the Yamuna's flow, leaving its sibling river to carve a new course. These watery battles remind us that mountains aren't the only forces sculpting the land. Rivers are alive too, shifting, adapting, and occasionally rewiring entire watersheds when geology gives them no choice. What's wildest of all, this drama isn't confined to the past. Satellite images reveal rivers in the eastern Himalayas still jostling for dominance today, their channels wriggling like snakes as erosion and uplift wage their endless tug of war. The next great capture could be centuries away or already underway, hidden beneath jungle canopies and monsoon rains. One thing's certain, in the Himalayas, even the rivers refuse to sit still. Standing nearly 5 miles high, the Himalayas don't just scrape the sky, they command it. These towering peaks act as a colossal barrier, forcing moisture-laden monsoon winds to rise, cool, and dump their burdens in a deluge that feeds half a continent. Picture the summer monsoon as a river of air flowing north from the Indian Ocean, charged with enough water vapor to drown entire landscapes. When this atmospheric freight train slams into the Himalayas, it has nowhere to go but up. As the air ascends, it expands and chills, squeezing out rain like a sponge wrung over the Gangetic plain. The result, a fertile belt so productive it's fed civilizations for millennia, from the Harappans to modern India's wheat fields. Without this mountain-made rainfall, much of South Asia would be as parched as the Sahara. Yet just a few hundred miles north, the story flips dramatically. While Bhutan's valleys drown in 12 meters of annual rain, enough to submerge a 4-story building, the Tibetan plateau languishes in a rain shadow so severe it's among the driest places on Earth. The same mountains that wring moisture from the air create a desert in their lee, blocking clouds like a dam. Tibet's landscapes tell the tale. Brittle grasslands where nomads herd yaks, salt flats that shimmer like shattered mirrors, and valleys so arid they preserve 1,000-year-old corpses in near-perfect condition. This isn't just local weather whiplash, it's a planetary-scale climate split, engineered by rock and altitude. But the Himalayas' influence doesn't stop at rainfall. The Tibetan plateau, heated by summer sun, acts like a colossal hot plate, warming the air above it until it rises in a perpetual updraft. This creates a pump that pulls moist air inland from the oceans, sustaining monsoons as far away as East Africa. Satellite data reveals how this thermal chimney even distorts the jet stream, sending ripples through global wind patterns that can trigger droughts in Texas or floods in Europe. Some scientists argue this mechanism is so powerful it may have helped plunge Earth into the ice ages. When the Himalayas rose, their sheer bulk altered atmospheric circulation, potentially cooling the planet enough to allow ice sheets to creep southward. Now consider this: the same mountains that shape climate also serve as Earth's most vital water tower. Their glaciers store more fresh water than anywhere outside the poles, feeding 10 major rivers that quench the thirst of nearly 2 billion people. From the Indus to the Mekong, these waterways are lifelines threaded with snowmelt. But as temperatures rise, the tower's taps are running erratic, sometimes gushing floods, other times threatening drought. The Himalayas giveth, and the Himalayas taketh away. One thing's certain: as long as these mountains stand, they'll keep rewriting the rules of weather, one monsoon at a time. The Himalayas aren't just a geological marvel, they're a living, breathing ark of biodiversity, a place where life clings to the edge of impossibility. Take the snow leopard, a ghost of the mountains whose thick, smoke-gray fur lets it vanish into the cliffs. This elusive cat thrives where oxygen is thin and temperatures plunge to -40, stalking prey across slopes so steep a single misstep means death. Then there's the red panda, a fiery-tailed acrobat that leaps through rhododendron forests, its jaws uniquely adapted to crush bamboo in a land where most plants refuse to grow. Even the Himalayan blue sheep, or barrel, defies expectations, a master of balance that grazes on near-vertical meadows, its hooves gripping rock like suction cups. These aren't just animals, they're evolutionary daredevils, each sculpted by mountains that demand perfection or extinction. What makes this possible is a phenomenon called altitudinal zoning, nature's version of a high-rise apartment building, where entire ecosystems stack vertically like layers of a cake. Start at the foothills and you're in lush subtropical forests teeming with tigers and elephants. Climb higher and the air chills, giving way to temperate oaks and maples, where langur monkeys chatter in the canopy. Keep ascending and the trees shrink into dwarves, twisted by wind into bonsai-like forms. Above them, alpine meadows burst with flowers so vibrant they seem photoshopped: blue poppies, primulas, and edelweiss clinging to thin soil. Finally, the realm of rock and ice begins, where even lichens struggle to survive. Each zone is a self-contained world, isolated by altitude and climate, creating pockets where evolution runs wild. Isolation breeds uniqueness. Cut off by valleys and peaks, species adapt in bizarre ways. Take the Himalayan jumping spider, a tiny acrobat that thrives above 4,000 meters, where most insects freeze solid. It survives by producing antifreeze proteins, allowing it to hunt in temperatures that would turn other creatures into popsicles. Or consider the golden langur, a monkey found only in a sliver of forest along the Bhutan-India border, its blonde fur a fluke of genetic drift. Even plants get creative. The rhododendron species that dominate these slopes secrete toxins into the soil, poisoning rivals to monopolize scarce nutrients. Every niche is exploited, every advantage amplified, because here, ordinary isn't enough. Yet this delicate balance is unraveling. As temperatures rise, the Himalayas' climatic layers are compressing like a collapsing elevator. Species adapted to cold are being pushed upward until, for some, there's nowhere left to go. Snow leopards now compete with common leopards, invading their high-altitude turf, while warmer winters allow pine beetles to ravage ancient forests. The most heartbreaking casualties are the specialists, the pika, a potato-sized relative of rabbits that can't survive even slight heat, or the Himalayan quail, last seen in 1876 and now presumed extinct. These losses ripple through the ecosystem. Fewer pikas mean fewer meals for snow leopards, whose decline lets herbivores overgraze, triggering landslides. The clock is ticking. Some scientists predict a third of Himalayan species could vanish by the century's end if warming continues. But there's hope. Conservationists are stitching together transboundary corridors, allowing animals like tigers and elephants to migrate as climates shift. Communities are replanting native forests and patrolling against poachers. Even tourists play a role. Responsible ecotourism funds protection while proving that living wildlife is worth more than trophies. The message is clear: the Himalayas' biodiversity didn't arise by chance. It's the product of millions of years of trial and error, a masterpiece we're only beginning to understand, and one we can't afford to lose. High in the death zone of Everest, where most climbers rely on bottled oxygen and sheer willpower, Sherpa guides move with effortless grace, carrying triple their weight while fixing ropes and reading the mountain's moods like a second language. These aren't just porters, they're the unsung engineers of Himalayan mountaineering, descendants of a people who turned high-altitude survival into an art form. Their secret, a genetic quirk that lets their blood carry more oxygen, honed over centuries living above 4,000 meters, but it's more than biology. Sherpa wisdom, like predicting storms by the taste of the wind or navigating whiteouts by the sound of ice cracking, has saved countless expeditions from disaster. When Edmund Hillary summited Everest in 1953, it was Sherpa Tenzing Norgay who broke trail through the final corners, proving that the world's highest peak wasn't conquered by outsiders alone, but through a partnership as delicate as the snow underfoot. Yet the Sherpa's relationship with these mountains runs deeper than climbing. In the shadow of Everest, the Tengboche Monastery stands as a spiritual beacon, its prayer flags fluttering in the jet stream. Here, monks recite ancient mantras not just for enlightenment, but to appease the mountain deities they believe govern avalanches and storms. Before each climbing season, lamas perform puja ceremonies where expeditions seek blessings, scattering rice and juniper smoke into thin air. It's a poignant fusion of faith and pragmatism. Ice axes and crampons laid beside butter lamps, modern adventurers bowing to traditions older than the compass. For the Sherpa, peaks like Chomolungma aren't trophies to be bagged. They're living entities, their summits forbidden to all but the most ritually pure. Centuries before Everest became a bucket list obsession, the Himalayas were already a crossroads of civilization. Caravans winding through passes like the 5,000-meter-high Nangpa La carried more than just silk and spices, they transported ideas. Buddhism flowed from India to Tibet along these icy trails, while merchants traded Himalayan salt for Nepalese rice in markets that thrived at altitudes where most crops refused to grow. The irony is striking. Today's climbers gasping for air on the same paths where yak trains once moved effortlessly, their drivers chewing raw garlic to ward off altitude sickness. These routes weren't just commerce, they were lifelines stitching together cultures across the roof of the world. Now, the mountains face a new invasion, not of traders, but of tourists. Base camps resemble small cities, with bakeries serving apple strudel and bars offering Wi-Fi alongside Chang local barley beer. Helicopters buzz like dragonflies, ferrying wealthy clients who pay six figures to experience the wilderness without leaving their comfort zones. The economic boost is undeniable. Schools, hospitals, and solar panels dot villages that once bartered for salt. But the cost is etched into the landscape. Oxygen canisters littering glaciers, human waste freezing into knee-on blue ice, and sacred summits trampled by queues of climbers elbowing for selfies. Local guides whisper about the yetis of old, not the mythical ape, but the ghosts of mountains now crowded out by commercial excess. The dilemma is as stark as the peaks themselves: how to balance reverence with revenue, tradition with progress. Some Sherpas have traded their ancestral farms for guiding careers, earning in a season what their parents did in a lifetime. Others resist, like the activists who staged a high-altitude trash cleanup, hauling thousands of kilos of garbage off Everest slopes. Meanwhile, monasteries now offer climbing permits alongside prayers, blending ancient rites with modern logistics. Perhaps the answer lies in the mountains themselves, eternally adaptable, weathering storms without losing their essence. After all, the Himalayas have always been more than rock and ice, they're mirrors reflecting back whatever we bring to them. The question is, what do we want to see? The Himalayas are no longer just the realm of climbers and mystics, they're now a high-tech laboratory where cutting-edge tools peel back layers of mystery hidden for millennia. Take LiDAR, the laser technology that strips away dense forest canopies like an X-ray, revealing ruins of lost kingdoms swallowed by time. In Nepal's Mustang region, these airborne lasers uncovered an entire network of ancient caves and fortresses carved into cliffs, their doorways sealed for centuries by landslides. Some chambers held Tibetan Buddhist manuscripts dating back to the 1200s, preserved by the dry mountain air. Elsewhere, drone surveys have mapped forgotten trade routes where yak caravans once hauled salt and silk across passes now buried under glaciers. These aren't just archaeological finds, they're pieces of a puzzle showing how humans thrived in one of Earth's most hostile environments long before Gore-Tex or GPS. But the real game changer is satellite radar, a technology so precise it detects ground movements as subtle as a millimeter. Known as INSAR, these orbiting sensors fire radar waves at the Himalayas day and night, measuring how tectonic stress bends the crust like a bowstring. The data is terrifyingly clear. Whole sections of Nepal are lurching southward by over 2 centimeters per year, building strain that will inevitably snap in future quakes. In 2017, scientists using this tech predicted the exact location of the devastating Nepal earthquake 2 years before it struck, proof that the mountains are whispering their secrets if we know how to listen. Yet some truths can't be gleaned from orbit. Enter the ice scientists who gamble with avalanches to plant sensors on crumbling glaciers. Teams like the International Center for Integrated Mountain Development rappel into crevices to install glacier heartbeat monitors, devices tracking melt rates with life or death urgency. One researcher described watching a serac the size of a skyscraper collapse minutes after retrieving data, the shockwave knocking him breathless. Their findings are dire. Himalayan glaciers have lost 40% of their volume since the 1970s, with some, like Nepal's Tisho Rolpa, threatening to burst their icy dams and drown valleys below. The next frontier, drilling straight into the Himalayas' spine. Ambitious projects like the In-Depth mission are probing deep beneath Tibet with seismic, thumpers, and diamond-tipped drills, extracting cores that reveal how continental collisions warp rock at unthinkable depths. Upcoming expeditions aim to penetrate the main Himalayan thrust itself, the fault where India grinds beneath Asia, hoping to decode the physics of megathrust quakes. It's like trying to read a recipe while the cake is still baking, with continents as the mixing bowls. What makes this modern exploration so revolutionary isn't just the tech, it's the collaboration. Sherpa guides now wield GPS units alongside ice axes, while monks in remote monasteries upload snowfall data via smartphone apps. Even satellites originally designed to spy during the Cold War now track glacier melt for climate science. The Himalayas, once considered impenetrable, are finally yielding their secrets not to conquerors but to curiosity. And with every pixel of LiDAR data, every creak of the crust measured by radar, we're learning something startling. These mountains aren't just a backdrop to human history. They're active participants shaping and being shaped by our shared future. For all we've uncovered about the Himalayas, some mysteries refuse to be solved, starting with the Tibetan Plateau, that vast, flat roof of the world stretching behind the jagged peaks. It's a paradox. How does a region forged by the most violent continental collision on Earth remain so eerily level, like a tabletop perched 5 kilometers in the sky? One theory suggests the plateau floats on a layer of molten rock, its weight spread evenly like a pancake on syrup. Others argue it's being sanded flat by wind and water, eroded as fast as India pushes it upward. But here's the twist: GPS measurements show parts of Tibet rising faster than erosion can wear them down, defying logic. The answer may lie deep underground, where chunks of the plateau's underbelly periodically break off and sink into the mantle, like icebergs calving from a glacier, allowing the surface to stay unnaturally smooth despite the chaos below. Then there's the ghost of the Tethys Ocean, an entire sea that vanished without a trace. We know its sediments now form Everest summit, but where did all that water go? Some was squeezed from the rocks like juice from an orange, bubbling up in hot springs or bonding chemically to minerals. But recent studies reveal something astonishing. The Tethys might still exist, just not in liquid form. As India plowed north, its leading edge likely dragged ocean water down into the mantle, locking it inside minerals like ringwoodite, a rare crystal that can trap oceans worth of H2O in its structure. If true, there's more water beneath Tibet than in all the Great Lakes combined, a hidden reservoir that could one day erupt back to the surface through volcanoes, rewriting our planet's water cycle. But the weirdest puzzles are the mountains themselves. While Everest grows taller, neighboring peaks like Nanga Parbat are actually sinking, their roots collapsing under their own weight like overbaked soufflés. Satellite data reveals entire valleys tilting sideways, pushed askew by subterranean currents we can't see. Even stranger, the missing earthquakes. Based on the strain building along the main Himalayan thrust, seismologists predict massive quakes every few centuries, yet historical records show eerie quiet periods lasting millennia. Some suspect the crust here creeps steadily, releasing stress silently. Others fear we're overdue for a catastrophic snap. This uncertainty fuels wilder theories. Could ancient myths hold forgotten truths? Tibetan texts speak of floating mountains that rise and fall with the moon's phases. A poetic idea until geologists found evidence of tides subtly flexing the crust. Sherpa legends warn of caves where time flows differently, echoing modern physics showing gravity warps time at high altitudes. Even the Yeti myth finds a bizarre parallel in paleontology. Could folk memories of extinct giant apes like Gigantopithecus, whose fossils litter the foothills, have inspired the tales? The truth may lie somewhere between science and story. After all, plate tectonics was once dismissed as fantasy, just like shifting mountains and underground oceans. Perhaps the Himalayas' greatest lesson is humility, reminding us that for every mystery solved, a dozen more emerge, whispering that our planet's grandest dramas are still unfolding, 1 millimeter at a time. Ancient Hindu texts whisper a story that sends chills down a geologist's spine. The tale of King Sagara's 60,000 sons, condemned to dig endlessly into the earth, their labors draining a primordial ocean until the gods intervene. For centuries, this was just myth. Then science uncovered the Tethys, that vanished sea whose remnants now crown Everest. The parallels are uncanny, an ocean disappearing into the depths, swallowed by forces beyond human scale. Could this be mere coincidence or something far more intriguing? Flood legends ripple through Himalayan cultures like seismic waves. In Bhutan, oral traditions describe a great lake bursting its banks, scouring valleys with watery fury. Scientists now find evidence of catastrophic glacial floods, mega tsunamis of meltwater unleashed when ice dams collapsed during ancient warm periods. The scars are still visible, boulders the size of houses stranded miles from any river, sediment stacked like pancakes by unimaginable currents. These aren't just stories, they're ancestral memories encoded in stone and song, passed down through generations who witnessed Earth's raw power firsthand. Indigenous knowledge often beats satellites to the punch. Sherpa elders have long predicted earthquakes by observing odd animal behavior, yaks bolting uphill days before the ground shook. Modern researchers initially dismissed this as superstition until they discovered animals might sense subterranean electrical pulses preceding quakes. Similarly, Tibetan herders track subtle changes in spring water chemistry, a practice now validated by studies linking mineral shifts to tectonic stress. When a Nepalese shaman points to a valley and says, "This place breathes," geologists listen because that valley sits atop a creeping fault line. The line between myth and data blurs in the Himalayas. Take the Lepcha people's belief that certain rocks are alive, pulsing with energy. Spectroscopy later revealed these stones contain piezoelectric minerals that generate voltage under pressure, exactly the kind of stress building along fault zones. Or consider Buddhist mandalas depicting concentric rings of mountains surrounding sacred peaks, eerily mirroring modern geologic cross-sections showing folded thrust belts radiating from the collision zone. Perhaps truth doesn't choose between science and legend, it dances in the space between. When a 17th century Tibetan monk wrote of mountains growing like bamboo shoots, he lacked GPS, but his metaphor captured the essence of tectonic uplift. Modern instruments confirm what intuition long suspected, that these peaks are restless, alive, and far more mysterious than either lab coats or prayer flags alone can explain. The real magic happens when both ways of seeing the world, the measured and the mystical, join forces to decode landscapes where logic and wonder share the same thin air. The Himalayas may seem eternal, but their future is anything but set in stone. Picture this: 50 million years from now, the crown of Everest might not be the planet's highest point. Current models show India's northward march slowing to a crawl, like a weary marathon runner reaching the final stretch. The force that built these peaks is fading, and as the Indian plate grinds to a halt, Everest's growth will stall. But here's the twist: erosion won't immediately win. Even without tectonic uplift, the mountain's sheer bulk will take millions of years to wear down, like a melting ice sculpture in slow motion. Meanwhile, gravity will wage its own war, causing the range's thickened crust to slowly collapse inward, like a cake sinking after baking. But Earth's tectonic drama never stops, it just changes stages. As India's saga winds down, another continental collision is brewing to the east. Australia, drifting northward at breakneck speed by geological standards, is on a collision course with Southeast Asia. Imagine the Himalayas' birth, but with a twist. Instead of a head-on smash, Australia might sideswipe the continent, crumpling islands like Indonesia into a new mountain belt. Some projections suggest future peaks could rival the Alps, their birth echoing the chaos that once raised the Tibetan plateau. It's a reminder that mountain building isn't a one-time event, it's a planetary habit. Yet humans are writing their own subplot in this geological epic. Dams like those planned along the Brahmaputra risk starving deltas of vital sediment, while mining operations chew into fragile slopes, triggering landslides. But the real wild card is climate change. Melting glaciers aren't just vanishing water sources, they're destabilizing the very rock beneath them. Thawing permafrost weakens mountain faces, and glacial lakes swell into ticking time bombs, threatening valleys below. The Himalayas could become a paradox, crumbling even as they rise, their fate tangled between natural cycles and human fingerprints. Now, here's a thought to bend your mind. What if we could steer tectonics? Far-fetched as it sounds, some scientists speculate about geoengineering projects to release built-up seismic stress or even manipulate plate movement. Think deep underground injections to lubricate faults or massive pumps to alter mantle flow. The ethics are murky, the risks colossal, but the ambition is pure Homo sapiens to tame the forces that shaped our world. Whether we should is another question, one that might define not just the Himalayas' future, but our own. After all, mountains teach patience. The real challenge isn't controlling them, it's learning to listen. Climate change isn't knocking on the Himalayas' door. It's kicking it down with a force that's rewriting the landscape before our eyes. While global temperatures creep upward, this towering realm is heating up 3 times faster than the planet's average, turning glaciers into ticking time bombs. Take the Khumbu Glacier near Everest, where ice that took millennia to form is now retreating at an alarming 60 meters per year, a pace so rapid that climbing routes shift seasonally and base camps relocate like nomadic villages. The meltwater doesn't just vanish, it gathers in unstable lakes dammed by rubble, their walls one storm away from unleashing floods capable of wiping entire valleys off the map. In 2013, one such outburst in Uttarakhand sent a tsunami of mud and boulders roaring through villages, leaving 6,000 dead in its wake. These aren't natural disasters anymore, they're climate change with a body count. But the crisis runs deeper than vanishing ice. Black carbon, soot from diesel engines, crop burning, and wildfires is darkening glaciers like a death shroud, accelerating their demise. Normally, pristine ice reflects sunlight back into space, staying cool. But when dusted with this fine black powder, glaciers absorb heat like asphalt, melting even faster. Satellite images reveal highways of soot drifting from industrial centers in India and China, settling on snowfields from Nepal to Bhutan. The cruel irony. These very glaciers feed rivers that quench the thirst of the nations polluting them, a self-destructive cycle unfolding in real time. Yet amid the despair, innovators are rewriting the script. Take Sonam Wangchuk, an engineer in Ladakh who noticed farmers struggling as springs dried up. His solution: ice stoop as conical towers of frozen water that act like natural reservoirs, slowly releasing meltwater through spring and summer. Built using nothing but gravity and freezing temperatures, these gleaming structures store winter runoff in elegant spirals that mirror Buddhist shrines, blending ancient wisdom with modern ingenuity. One stupa can hold millions of liters, turning barren fields green again. Villagers from Pakistan to Bhutan are now adopting the technique, proving that sometimes the simplest ideas punch far above their weight. The stakes couldn't be higher. These peaks don't just inspire awe, they anchor the planet's climate systems. The Himalayan glaciers feed 10 major rivers, sustaining nearly 2 billion people who rely on their waters for drinking, farming, and hydropower. As the ice vanishes, so does the steady drip of meltwater that once balanced wet and dry seasons. Farmers now face a nightmare scenario: violent floods in spring as glaciers hemorrhage water, followed by brutal droughts when the reserves are spent. The Brahmaputra, Ganges, and Indus, rivers that birthed civilizations, are becoming erratic beasts, their moods swinging between famine and fury. This isn't just an environmental story, it's a humanitarian emergency with a countdown clock. Scientists estimate that even if global warming stabilizes, 1/3 of Himalayan ice will vanish by 2100, leaving gaping holes in food and water security. The solutions, though, are as interconnected as the mountains themselves. Cutting black carbon could buy decades for glaciers, while reforesting slopes stabilizes soil against landslides. Solar-powered irrigation eases pressure on vanishing streams, and policy shifts can redirect subsidies from thirsty crops like rice to drought-resistant millets. What's missing isn't knowledge, it's the collective will to treat these peaks as more than scenic backdrops. The Himalayas aren't just on our maps, they're in our mirrors, reflecting back what we prioritize. Save them and we save ourselves. Ignore them and the consequences will ripple far beyond these slopes, reshaping lives in cities and farmlands thousands of miles away. The mountains are speaking. The question is, are we listening? In the shadow of melting glaciers and vanishing species, a quiet revolution is unfolding across the Himalayas. One where tradition and innovation collide to protect the planet's most fragile frontier. Take Bhutan, the tiny kingdom that turned its entire country into a climate sanctuary. While most nations struggle to cut emissions, Bhutan isn't just carbon neutral, it's carbon negative. Its forests absorbing 3 times more CO2 than its citizens produce. How? A constitution that mandates 60% forest cover for eternity, hydropower replacing fossil fuels, and free electricity for farmers to curb wood burning. But the real genius lies in their spiritual calculus. Every tree felled requires 3 planted, turning Buddhist reverence for nature into policy. The result? A nation where rivers run wild, tigers rebound, and snow leopards stalk protected valleys, proof that environmentalism can be woven into a country's DNA. Meanwhile, Nepal's community forests rewrite the playbook on conservation from the ground up. 35% of the country's forests are now managed by local groups, grandmothers patrolling for poachers, schoolchildren mapping biodiversity, and former loggers earning more as eco-guides than they ever did cutting trees. In the Annapurna region, villages once plagued by deforestation now boast thicker canopies than 30 years ago, with endangered red pandas returning to regenerated woodlands. The secret: handing power and profits back to communities. Every tourist dollar from trekking permits funds schools and clinics, while honey harvested from Himalayan cliffs by indigenous honey hunters fetches premium prices as a sustainable delicacy. It's a blueprint for how conservation thrives when it puts people first. On Everest slopes, a different cleanup operation unfolds. Climbers who once left oxygen canisters and frozen tents in their wake now compete for Eco Summit, bragging rights, hauling down more trash than they carry up. Expeditions like the Sagarmatha Pollution Control Committee pay Sherpas bonuses per kilo of waste retrieved, turning base camp into a recycling hub where even human waste gets packed out in biodegradable bags. The numbers stagger: over 25,000 kilograms removed since 2019, including relics like 1960s-era canned food and shredded nylon ropes from Hillary's era. But the real victory, a cultural shift where leaving debris earns shame, not shrugs, transforming mountaineering from conquest to custodianship. Then there are the unsung heroes fighting for the Himalayas' most elusive ghost, the snow leopard. In Ladakh's high deserts, conservationists like Riggs in Dorje work with Buddhist monks to turn monasteries into anti-poaching watchtowers. Ancient scriptures that forbid killing now protect mountain spirits, their term for snow leopards, while herders receive insurance payouts for livestock lost to predation. No retaliation needed. Camera traps reveal cubs playing in once empty valleys, their populations rebounding as communities learn the value of a living leopard over a poached pelt. Similar triumphs echo in Pakistan's Hindu Kush, where wildlife corridors let leopards safely cross military zones, and in Mongolia, where GPS collars track their movements to prevent herder conflicts. These aren't isolated wins, they're threads in a larger tapestry of hope. When Indian villages install solar-powered ice stupas to combat water scarcity, or Nepali teens build landslide sensors from recycled smartphones, they prove that saving the Himalayas isn't about grand gestures but countless small acts of ingenuity. Even tourism, long the region's double-edged sword, is being reinvented. Luxury lodges now run on yak dung biogas, and trekkers volunteer as citizen scientists, documenting glacial retreat with every step. The lesson, the roof of the world isn't beyond repair. It's a living lab for what humanity can achieve when we listen to those who know these peaks best. The road ahead remains steep. Melting glaciers still outpace replanted forests, and poachers still lurk in shadowed valleys. But the Himalayas have always been a place of paradox, where thin air nourishes deep resilience and isolation sparks connection. From Bhutan's carbon-negative pledge to Sherpa's guiding trash off Everest, these stories whisper a truth louder than any avalanche, that the mountain's fate isn't sealed. It's being rewritten, one act of defiance against despair at a time. And if there's one thing the Himalayas teach us, it's that even the mightiest forces, whether tectonic or human, can be nudged toward grace. From sacred myths whispered by ancient pilgrims to the seismic hum of tectonic plates captured by satellites, the Himalayas have always been both a riddle and a revelation. We've traced the footsteps of geologists who cracked the code of continental drift, decoded the whispers of fossilized seashells on Everest's summit, and even glimpsed the ghost of an ocean hiding in crystals deep beneath Tibet. Yet for every mystery solved, the how, the when, the mechanics of this colossal collision, a dozen more emerge, shimmering like mirages in the thin mountain air. Consider this paradox. The Himalayas are Earth's mightiest fortress, yet they're also its most fragile barometer. These peaks don't just shape weather, they hold entire civilizations in their icy grip. A single degree of warming here can unleash floods that drown villages or droughts that wither crops 1,000 miles downstream. They're a living climate dial, turning imperceptibly until suddenly the consequences roar through river valleys and monsoon cycles. And just as they govern rain and wind, they anchor cultures, from Sherpa guides reading avalanches in the flutter of prayer flags to Bhutanese monks charting glacier retreat alongside satellite sensors. The Himalayas are where science and spirit share the same trail, each step revealing how deeply interconnected our world truly is. But wisdom here comes with urgency. The same peaks that survived asteroid impacts and ice ages now face a threat no geological era prepared them for: us. Melting glaciers, choking pollution, the relentless press of tourism, these aren't just challenges. They're choices: to trek responsibly, leaving no trace but footprints, to advocate for policies that protect meltwater lifelines, to listen to indigenous voices who have navigated these slopes for centuries, their knowledge as vital as any GPS grid. So let's end where we began, with awe. Whether you're a climber lacing boots at base camp or an armchair adventurer tracing these peaks on a screen, remember the Sherpa proverb that cuts to the heart of it all. The mountain does not care if you are small, only if you are wise. These giants have witnessed continents collide and cultures rise and fall. Their lesson isn't about conquest but humility, the kind that fuels curiosity, demands respect, and just maybe will keep this wonder alive for the next generation of dreamers and discoverers. The Himalayas aren't just rocks and ice, they're a mirror. What will they reflect